problem. Okay. First, we're going to start off by trying to find the equivalent resistance. So starting with this section, in order to find the equivalent resistance, you take the 1 over R in Q, and so the equivalent resistance of this portion of the circuit would be 1 over 4 plus 1 over 12, and okay. So 1 over 4 is the same thing as 3/12 plus 1/12 is equal to 4/12. And then, no, sorry, is equal to 4/12, and 4/12 is equal to 1/3. So the equivalent resistance of this area is equal to 3.
You left me out. You just said don't lock me out, sorry.
Okay. Can you pause it?
No,
Can you?
it's fine.
Okay, so once we... Okay, now we want to find the total resistance of the circuit. So we take the resistance of this area, which is 5, plus the resistance of this portion, which we found out was 3, and add the final resistance at the bottom, which is 8. And this is equal to 5 plus 3 is 8, plus 8 is equal to 16. So
Red.
the total...
Do it in red.
The total resistance is 16
Ohms. There you go.
So by Ohm's law, we get that 24 is equal to I, and then times the total resistance, which we found was 16. So if we divide 24 by 16, we find the total current going through the circuit. So 24 divided by 16 is equal to 1.5. And that means the total current would equal... Current is in
Amps.
amps. So both the first resistor and the fourth resistor have the total current as well as the same amount of current going through them. So the value of current in both of these resistors would be equal to 1.5 amps.
Now write it up there in red. For I1 and I4.
Wait. 1.5?
Uh-huh. Okay.
Because we know the resistance and the current going through R1 and R4, we can use Ohm's law to figure out the potential, electric potential difference. Let's look at here.
You feel me? Okay, so we know the total voltage of the circuit is 24 volts, and we just calculated the voltage, the electric potential difference, excuse me, across the first resistor and the fourth resistor to be 7.5 and 12 respectively, and 12 plus 7.5 is equal to 19.5 volts. So that means that 19.5 volts are dropping across here and here. So to get the rest of the 24, we need 4.5 to drop along this parallel branch. And we know that the defining characteristic of parallel circuits is that the voltage in the parallel branches is equal, so I know 4.5 volts drop from here to here and on here to here and here to here. So we can put that for the voltage across 2 and 3 in red. And because we know the resistance of each resistor and the electric potential difference over each resistor, we can use Ohm's law to calculate the current across each resistor, one of these two right here. So V 4.5, we'll do R2 first, equals I times R, which is 4 ohms. 4.5 divided by 4 is 1.125, so the current across resistor 2 is equal to 1.125 amps. So, oh no, red. Sorry. 1.125 amperes. Using the same law, Ohm's law, we can find the current across the third resistor. So the voltage is the same, 4.5 equals I times the resistance, which is 12. Close parenthesis. 4.5 divided by 12 is 0.375. So the current is equal to 0.375 amperes. So to fill in our table with the last value, we have the current across resistor 3 to be 0.375 amperes.
We'll go.
Physics.